There is a voice problem.
Voice problem, no?
You can continue. After half an hour, you can continue with this.
After half an hour. సరే ఇది ఇప్పుడు అక్కడ ఛార్జింగ్ అదంతా ప్రాబ్లం ఏం లేదు కదా, కంటిన్యూ కదా. ఇప్పుడు ఇక డైరెక్ట్ కంటిన్యూ చేయాలి ఇది.
మీరు ఎన్ని గంటలైనా వర్క్ చేసుకోవచ్చు ఎందుకంటే ఇట్ ఇస్ డైరెక్ట్లీ ఛార్జ్.
అది ఇంక మన స్టిప్స్ అదేం ప్రాబ్లం లేదు కదా, అదే మరి.
అదేమీ లేదు.
సరే డోర్ వేసుకోవాలా?
యా యూ కెన్ డూ.
మళ్ళీ స్ట్రీమింగ్ కొట్టాలా మళ్ళీ ఇప్పుడు చెప్పాలా డైరెక్ట్? ఇంకా స్ట్రీమింగ్ మళ్ళీ ఆప్షన్ అవసరం లేదు కదా. Okay, welcome back students. A very good evening to everyone. This is Chandra Prakash, the faculty of chemistry, especially for ECET, and myself. I have completed my graduation or post masters from Usmania University, and in the department of chemistry. And I have previously worked with many institutions, especially like these kind of institutions. Now, in today's topic, colloids and solution. First of all, before going to start the session, this is ECET coaching, especially for the polytechnic students. This is Ask Engineering Academy, which is located at Dilsukhnagar at the heart of the Hyderabad. It has a rich experience in motivating the students, young minds, especially in the field of ECET from the past many years. So now if you want to join this academy, you can get all the details regarding this institute, especially in the link which is provided in the description. So now in the last class we have already completed the concept of solutions, because the chemistry is a subject which is an interlinking subject, because one concept is highly interlinked with other. Without proper understanding of one topic, you can't understand the next topic, because they are like interlinking, because one can understand one topic then after other topic. If without knowing the previous topic, you can't go into the depth of next topic. So first the chemistry will start with the atomic structure, which is very basic concept in chemistry. If you have an idea about atomic structure, then we move to chemical bonding, and then we move to solutions and colloids. Solutions and colloids, in the sense, first of all, the motive of this concept and an introduction of this concept especially is that solutions and colloids. Before starting this topic, we need to know some kind of basic terminology in chemistry, such as states of matter. What is mean by states of matter? States of matter in the sense, anything that has a perfect size and shape. For example, this is a pen. It has some size and it occupies certain amount of space. So anything, if they obeys these two conditions, that is, one is occupying the space, one is having proper size and shape, those are considered as matter. Again, the matter can be classified into three types: solids, liquids and gases. Because when you observe the entire universe around us, మన చుట్టుపక్కల చూసినప్పుడల్లా మనకు కనపడుతూ ఉంటాయి. Certain kind of substances exist as solids, certain kind of substances exist as liquid, certain kind of substances exist as gases. So these are all the examples of matter, in which again they classified into three types, like solids, liquids and gases. Solutions and colloids. What is the importance of studying solutions and colloids? This is my question to you. So you can comment in the comment box also. If I ask you any kind of questions, you can, without any further delay and without any hesitation, you can answer all the questions whatever I ask in the live session. And this is solution and colloids. First of all, I want to give you a brief about what are the contents generally have, especially in this topic. We start with solution introduction. Then move on to definition of solution. This is the first important topic, especially in this regard. Next, moving on to solubility. It is also very, very important. It is a kind of property of solutions. So you can get the more information once we are moving on to solution, why the concept of solution in colloids is actually introduced only because of solubility. So how much important the solubility you can able to know at the end of this chapter. Next, classification of solutions is also very important. Classification of solution means many solutions are there which have diverse properties. Diverse in the sense రకరకాల ప్రాపర్టీస్ ఉంటూ ఉంటాయి సొల్యూషన్స్కి. అంటే ఒక్కో సొల్యూషన్ ఒక్కొక్క రకంగా ఉంటుంది. అంటే వన్ సొల్యూషన్ ఈజ్ నాట్ సేమ్ యాజ్ అదర్ సొల్యూషన్. ఈచ్ అండ్ ఎవ్రీ సొల్యూషన్ హ్యాస్ సమ్ డిఫరెన్సెస్ యాజ్ వెల్ యాజ్ సమ్ సిమిలారిటీస్. ఈక్వల్గా ఉంటాయి, కొన్నిసార్లు డిఫరెన్సెస్ కూడా చూపిస్తాయి. అందుకే వాటిని ఎలా క్లాసిఫై చేస్తామనేది కూడా వెరీ వెరీ ఇంపార్టెంట్. సో క్లాసిఫికేషన్ ఆఫ్ సొల్యూషన్స్ ఈజ్ ద వన్ కైండ్ ఆఫ్ టాపిక్ ఇన్ దిస్. బేస్డ్ ఆన్ physical state. Based on physical state means whenever we observe any substance, absorbing substance is physical. We are physically seeing this substance, physical appearance. అంటే మనం చూస్తూ ఉన్నాం, మన కంటితో చూస్తున్నాం, అది కనపడుతుంది. సో ఇట్ ఈస్ అ ఫిజికల్లీ లొకేటెడ్ అండ్ ఫిజికల్లీ రికగ్నైజబుల్. కాబట్టి బేస్డ్ ఆన్ ద ఫిజికల్ స్టేట్, అది ఉండేటువంటి స్థితిని ఆధారంగా చేసుకొని depending upon the physical state of the solution, the solutions are classified into many types. Later we are moving on to very very important topics. One is atomic weights. Every chemistry students should must understand what is meant by atomic weight, what is meant by molecular weight, because these are the basic concepts. These are the always an important concept, especially learning chemistry and also concept of chemistry. Without having any knowledge on these kind of concept, you can't conquer in the sense సాధించడం. కెమిస్ట్రీలో ఒకటి మీరు సాధించాలి అంటే తప్పకుండా దానిలో ఉన్న మూలాలను తెలుసుకోవాలి. అంటే యూ హ్యావ్ టు నో వాట్ ఆర్ ద బేసిక్స్ ఇన్వాల్వ్డ్ ఇన్ దట్ సబ్జెక్ట్. సో ఫర్ కెమిస్ట్రీ, మాలిక్యులర్ వెయిట్, అటామిక్ వెయిట్, ఈక్వివాలెంట్ వెయిట్, మోల్, all these concepts are basics. Without proper understanding or proper idea of these basics, you can't move into further level. So this is what we are going to discuss. Next, molecular weight, equivalent weight and mole concepts, molarity, normality. Next, numerical problems on mole, molarity and normality. It is also very important. Now, colloids. So far we have discussed, that means solutions. After the completion of solutions, colloids there. It is also a specific branch. The colloids also plays a vital role, especially in the human body. So colloids is also one such branch of chemistry in which types of colloids can be, how the solutions are classified. In the similar way, the colloids are also classified into various types. In this we usually study leophilic, leophobic colloids and protective colloids and gold number, properties of colloids and industrial applications of colloid. Industrial applications in the sense how the properties of colloids are useful especially in industrial purposes. For example, there is a big industry. In order to produce certain kind of compound, we need certain kind of colloids. So in order to develop a compound from the colloids, అంటే ఒక మెటీరియల్ తయారు చేయాలంటే మనకు కొల్లాయిడ్ అవసరం. కొల్లాయిడ్ అవసరం చేసుకొని మనం ఒక మెటీరియల్ని అక్కడ ఫామ్ చేస్తున్నాం, ఒక ప్రోడక్ట్ని తీసుకుంటున్నాం. కాబట్టి ఆ ప్రోడక్ట్ యొక్క క్యారెక్టరిస్టిక్స్ ఏవైతే ఉంటుందో, ఇన్ ఆర్డర్ టు ఎక్స్ప్లెయిన్ ద క్యారెక్టరిస్టిక్స్ ఆఫ్ ద ప్రోడక్ట్స్ వీ మస్ట్ నో ద ప్రాపర్టీస్ ఆఫ్ కొల్లాయిడ్స్. కొల్లాయిడ్స్ ప్రాపర్టీస్ మనం సరిగ్గా తెలిస్తేనే ఎట్ ద ఎండ్ ఆఫ్ ద థింగ్ వీ నో వాట్ ఈస్ ద ప్రోడక్ట్ విచ్ ఈస్ ఫార్మ్. ప్రోడక్ట్ యొక్క డీటెయిల్డ్ ఇన్ఫర్మేషన్ ఎప్పుడు వస్తుంది మనకి, దాంట్లో యూజ్ చేసిన రా మెటీరియల్కి సంబంధించిన ఇన్ఫర్మేషన్ అంతా మన దగ్గర ఉన్నప్పుడు మాత్రమే అది సాధ్యపడుతుంది. సో సింప్లీ industrial applications of colloids. Why the colloids are very important, especially in terms of industry. Also we discussed at the end of chapter. So this is all about, it is a very brief and a very short and sweet concept of colloids. Now we are moving on to actual topic, that is solutions. Actual topic, that is solutions. Just a minute. And first we move on to, so already in the last class I have explained, but in order to get idea and to refocus and to regain the focus on this again, this object, to get an idea, I will explain again. Solutions and colloids. I already explained what is meant by matter, solid, liquid, gas, anything that has definite shape and size, all the substances are considered as matters. Now, what is meant by solution? Solution in the sense, solution is an example of homogeneous mixture. Homogeneous mixture in the sense, for example, see, this is a beaker, this is a solution. This solution is termed as an example of homogeneous mixture. Homogeneous mixture means generally mixtures are classified into two types. Mixtures are classified into two types. One is homogeneous and heterogeneous. Homogeneous and heterogeneous mixtures. Homogeneous mixtures and heterogeneous mixtures. What is meant by homogeneous mixture? I am saying that mixture in the sense it is not a single thing. It is a combination of two different components. For example, see once. For example, A plus B plus C is equal to ABC mixture. This is considered as ABC mixture. ABC mixture. This ABC mixture, for example, classified into two types. One is homogeneous, one is heterogeneous. What is meant by homogeneous? For example, if any mixture in which all the components are equally distributed. For example, this is a solution. These are the A, B, C, D. These are the components. This is a homogeneous mixture in which A, B, C, D are four different components. If these four different components are equally spread or equally distributed in this solution, then this is called as homogeneous mixture. If not, it is heterogeneous mixture. I will explain with one example, that is, for example, coffee. I think you are very like to drink coffee because it is a very habit. So sometimes it is also an addiction to some kind of people also. Without coffee they can't even stay. So coffee, for example, if you take coffee, if you taste it, any portion of coffee, for example, this is a glass, it contains, for example, 50 ml or 60 ml of coffee. This amount of coffee, if you take any portion of that coffee from 50 ml, it tastes same because all the contents, all the things what we are added in the preparation of coffee are equally spread or evenly distributed. These are called as evenly. Evenly in the sense equally, evenly distributed. Evenly distributed so that whenever we take or whenever we taste any portion of coffee, it tastes similar. Similarly, cool drinks, Thumbs Up, Coke, Sprite, Fanta, anything. If you taste it, any portion, it smells and tastes similar because of homogeneous nature of that mixture. That is called as homogeneous mixture. So, now the solutions are also examples of homogeneous mixtures because the components in the homogeneous mixtures are equally distributed. Similarly, in the solution also the components are equally spread or equally distributed. Now, based on the components, what are the components? I am always saying components. What are those components? In the solution especially, there are two types of components will be there. For example, solution contains especially two types of components. One is solute, one is solvent. One is solute and solvent. What is meant by solute? Solute in the sense Solute, solvent, these are the two components by which the solution is prepared. So coming to the explanation of this solute and solvent, now we are moving on to what is meant by solute. For example, this is an example of sugar water. Sugar, it is solution of sugar and water, H2O. I am writing simply H2O, sugar and water. This is an example of solution, sugar solution. In this, two components are there. One is sugar, another one is water. In which among these two things, between these two components, what is the solute and what is the solvent? Now, solute is the sugar, solvent is the water, because solute is a sugar. Solute means a solute is a substance that is generally present in smaller proportions or smaller amounts. Solute means a solution that has two components, solute and solvent. Sugar is a solute because solutes are generally the substances which are generally present in smaller proportions than the solvent. Solvent means water. Whenever if you observe the sugar water, the proportion of sugar is this much, the proportion of water is this much. So solvents are highly efficient and highly more, always they are in larger amounts or larger composition. So solvents are the substances which are in larger proportions compared to solutes. This is the sugar is the solute and water is the solvent. This is a solute. This is a solute and water is a solvent. This is how the solute and solvent will be categorized, and depending upon, and this is what sugar water, salt water, these are all the examples for solutions. Now in most of the cases, in majority of the cases, the solvents exist as liquid, but it is not same in all the cases. It is not same all the cases. అన్ని సందర్భాల్లో solvent liquid state లోనే ఉండాలని ఏం లేదు, but majority of the cases and most of the times the solvent will exist as liquids. And for example I will give very important examples for solution. There are three important examples generally everybody going to discuss when there is a concept of these types of techniques or topics, and those three examples are homogeneous mixture examples. Homogeneous mixtures, the best examples for homogeneous mixtures in order to make you understand homogeneous mixtures. Homogeneous mixtures, there are basically three very important examples. One is air, second one is sugar syrup, third one is tincture of iodine. Tincture of iodine. So these are the best examples. How these are considered as solutions, I will make you understand now. For example, air. Air is an example of homogeneous mixture. How? Air contains many particles. Air contains different types of gases. For example, oxygen, nitrogen, every gas will be there. It is a combination of many gases and many pollutants. So it is called as a homogeneous mixture. Now sugar syrup. What is mean by sugar syrup? Sugar syrup in the sense pakam antam chudandi manam pakam. For laddu, for the preparation of laddu, for the preparation of different types of sweets, we usually make the sugar syrup. It is generally formed as a result of dissolving a minimum amount of sugar in minimum amount of water. ఒక వాటర్లో షుగర్ని వేసి డిజాల్వ్ చేసినప్పుడు it forms a thick layer. That thick layer is called as sugar syrup. So sugar syrup is also an example of sugar plus water is an example of solution. Next, tincture of iodine. What is meant by tincture of iodine? I think you are completely unfamiliar with this word, that is tincture of iodine. Tincture of iodine in the sense when if you take alcohol, certain amount of alcohol, for example 50 ml or 25 ml of alcohol. If you take some amount of alcohol in iodine or iodine in alcohol, then the mixture of alcohol in iodine is called as tincture of iodine. Tincture of iodine in the sense, the mixture of iodine and alcohol. Tincture means alcohol plus iodine. Alcohol plus iodine means tincture of iodine. These are the examples for solution, because alcohol exists as liquid, iodine exists as liquid. Here liquid, homogeneous mixtures. They are together evenly distributed between them. So this is the most important examples for homogeneous mixtures. Now moving to the next topic, that is solubility. What is meant by solubility? I already said, if you really want to understand the concept of solutions and colloids, you must get an idea about solubility. Solubility in the sense, it is a property of solute. Actually, it is a property of solute. I am writing here, please see here, it is a property of solute. We know that, for example, see, 30 grams of sugar. I am taking 30 grams of sugar is dissolving in 500 ml of water. 30 grams of sugar is placed in 500 ml of water. After some time, the sugar may disappear because there is a complete dissolution of sugar within the water. So this is called as solubility. That means solubility is defined as, it is the property of the solute at what rate or at what speed it is dissolving in the particular solvent. ఏ సాల్వెంట్లో అయితే ఏ సొల్యూట్ ఎంత అమౌంట్తో డిజాల్వ్ అవుతుంది, అదే solubility. The amount of solute usually dissolves in a solvent is called as solubility. And solubility mainly depends upon, the property of solubility mainly depends upon three important parameters or three important factors. One is temperatures, one is pressure, third one is nature of solute and solvent. Nature of solute and solvent. Based on these three parameters, based on these three things, the solubility of a solute usually depends. Now coming to the first concept is temperature. How the temperatures influences the rate of solubility. Temperature always directly proportional to solubility. That means if you increase the temperature, the solubility also increases. If you increase the solubility, it directly proportional to temperature in the sense, the solubility increases with increase of temperature. As the rate of temperature increases, the rate of solubility also increases. I will explain how. See, for example, what happens when we heat solutions? See, this is a beaker. For example, there is a solution in it. Now we are heating the solution. What will happen when we heating? We already know that heat is the form of energy. Heat అనేది ఒక ఎనర్జీ ఎప్పుడైతే మనం ఒక సిస్టమ్కి సొల్యూషన్కి ఇస్తున్నామో, the molecules or the components within the beaker get excited. అవి ఎనర్జీని తీసుకొని ఎగ్జైట్ అయిపోతాయి. By excitation it will move randomly here and there. అలా ఆ మాలిక్యూల్స్ మూవ్ అవి కంటిన్యూగా మూవ్ అవుతూ ఉంటాయి, రష్లో ఉంటాయి. దర్ ఇన్ ఎ గ్రేట్ రష్ టు మూవ్. సో మూవ్ అవి ఏమవుతుంది, అవి సాల్యుబిలిటీ అనేది ఈజీగా సాల్యుబుల్ అవుతుంది. వెన్ ఎవర్, ఫర్ ఎగ్జాంపుల్ దిస్ ఈజ్ వన్ బీకర్, ఫర్ ఎగ్జాంపుల్ ఇమాజిన్ దిస్ ఈజ్ అనదర్ బీకర్. Take sugar in this beaker and take sugar in the beaker. Now check the rate of solubilities in these two beakers. This is by heating, this is without heating. You generally observe that the rate of solubility in this case is more because there is heating. Due to heating, the kinetic energy within the molecules increases. Because of that kinetic energy, the solubility also increases. So that is what solubility directly proportional to temperature. Okay. And what will happen when solubility will be formed? Whenever we add solute to the solvent, there is a chance of formation of bond between solute, between solvent. For example, this is a solute, This is pen is a solvent. So when they are comes in contact with each other, there is an interaction between solute and solvent. This process is called as solubility. The solubility is nothing but it is a kind of interaction between solute and solvent molecules leads to the formation of solution. This is the basic definition of solubility. And now types of solubility. Types of solubility means solubility also again classified into three types. Solubility also basically depend three types. For example, so I am writing here, just see here. So I am writing about classification of solubility. Classification of solubility. In the previous slide I am explaining on this slide. Solubility means depending upon the degree of dissolving power of solute. అంటే solute ఎంత రేట్తో soluble అవుతుందో దాన్ని డిపెండ్ చేసుకొని solubility are classified into three types depending upon the degree of dissolution. Depending upon the degree of dissolution of solute and also solvent, the solubilities are three types. One is very important, these are soluble type, or this is also called as miscible. Second case, insoluble or immiscible. Insoluble or immiscible. Third case, sparingly soluble. Sparingly soluble. These are the three types of solubility. This classification is based on how much speed the solute is dissolving, how much rate or how much extent the solute is dissolving in the solvent is called as these cases. Solubility, this is what solubility. And now soluble or miscible. For example, A plus B. A is a one component, B is another component. If A, B are mixed together completely, A is added into the B. If there is a complete dissolution of A in the B, you can't identify what is A and what is B at the end of the reaction. So that kind of solutions which are completely interacted, sugar solutions, salt solutions, such kind of solubility is known as miscible, completely colloided or completely interacted. Those are called as miscible. For example, for miscible, generally the best example for miscible is milk in water. Best example is milk plus water H2O. You know very well, milk is a very basic and essential need of every human being. So milk and water, if you add water to the milk, you can't separate the water from the milk because they are completely dissolved together. Because of that reason, milk in water is an example for miscible. Immiscible in the sense, milk in cereal, milk plus cereal. Cereal in the sense, pulses or cereals antam chudandi manam. If milk added to oats, for example oats, we usually get an idea about oats, cereals, ragi java, everything. If you add milk to those components, you can clearly visualize what is meant by milk and what is meant by cereal in that, because they are not that much closely interacted because of immiscibility and the condition name immiscibility, because they are not that much interacted together. Those called as immiscible solutions or immiscible solubility. Now sparingly soluble means, it is also very important thing. You just remember this what is the term that is sparingly soluble. Sparingly soluble means sometimes whenever you add one thing into other, there is no complete dissolution and there is no undissolution. For example, phenol water system, this is very important. Try to remember, I think one of your ECET previous question paper also asked this, phenol plus water. If you, in the beaker, if you take phenol plus water, if you observe this system, when you add these two components together, there is no 100% dissolution. Some amount of phenol dissolved in water, some amount of water dissolved in phenol, but not 100%, 50-50, miscible 50, immiscible 50. Those kind of systems are called as sparingly soluble. So based on this, solubility are classified into soluble or miscible, insoluble or immiscible, sparingly soluble. This is what solubility properties. Now we are moving on to properties. Already we have explained what is meant by temperature. As increase the temperature, increase. As the temperature increases, the rate of solubility increases. But there is an exception for this. In chemistry, every concept has some exceptions. అంటే కొన్ని ఉంటాయి ఎక్సెప్షన్స్, అంటే అవి దానికి ఒక రూల్ చెప్పాము అంటే ఆ రూల్కి అవి ఒబే కావు. సో దోస్ కైండ్ ఆఫ్ థింగ్స్ ఆర్ ఎక్సెప్షన్స్. సిమిలర్గా కెమిస్ట్రీలో చాలా ఎక్సెప్షన్స్ ఉంటాయి, అంటే దే కాంట్ ఎక్స్ప్లెయిన్ ఇన్ ఎ డీటెయిల్డ్ కట్. సో వన్ సచ్ example is that I already said, as the temperature increases, rate of solubility increases, but it is not applicable to the gases, because for example, this is beaker. For example, it contains N2, O2, H2 gases. I am heating this solution. I am heating this. What will happen? Generally, I said when we increase the temperature of the system, the rate of solubility increases. But it is not applicable for gaseous system, because when you heat it, when you heat the gases, the molecules within the gases expands like this. For example, initially the gases molecules are like this arranged. When you heat it, these molecules are randomly expands, and on further increasement of heat, అంటే మళ్ళీ ఫర్దర్గా మనం అలానే హీట్ చేస్తూ ఉంటే ఆ మాలిక్యూల్స్ అన్నీ కూడా ఆ సర్ఫేస్ నుండి ఎస్కేప్ అయిపోతాయి. సో దెర్ ఈజ్ నో సాల్యుబిలిటీ అట్ ఆల్. సో gaseous substances are the exceptions for the increase of solubility upon heating. So this is an exception, because these molecules will expand like this tends to expand. So expand signal, so escaping from the solvent. So whenever we heat, all the molecules within the gas try to expand like this and try to escape from the solvent within the solutions. So that's why solubility increases as temperature decreases in the case of gases. This is very important. Now next thing, another important parameter is pressure. How the pressure will be reflects or influences the rate of solubility. Now coming to this thing, now solubility. Now, and one more thing, what is meant by how the pressure will be useful in determining the solubility. Pressure in the sense, for example, the parameter pressure is completely different from the temperature. Temperature is one such kind of parameter, and pressure is one different kind of parameter. In terms of temperature, the temperature increases, solubility also increases. but in the case of gases it is not applicable. Similarly, certain kind of exceptions are also there with pressure also. Effect of pressure, this is pressure. Now the solubility also directly proportional to pressure. The solubility also directly proportional to pressure. Solubility directly proportional to pressure. Solubility directly proportional to pressure. As pressure increases, the rate of solubility also increases, but it is not all the times. In the case of solids, liquids, this case is not applicable because, for example, this is a ball, for example, this is the square. These are examples for solids. If you apply the pressure on the solid such as ball and this, that is known as compression, we are compressing the substances. If you are applying pressure due to close intermolecular interactions, ఒక బాల్ మీరు తీసుకున్నప్పుడు ఆ బాల్లో ఉన్న మాలిక్యూల్స్ అన్నీ కూడా క్లోజ్గా ఇలా ఇంటరాక్ట్ అయ్యి ఉంటాయి. సో వెన్ ఎవర్ యూ అప్లై ప్రెషర్, ఇట్ ఈస్ నాట్ దట్ మచ్ ఈజీ టు మేక్ ఇట్ సాల్యుబుల్. ఆ ఫోర్సెస్ని మనం అంత ఈజీగా బ్రేక్ చేయలేం. సో దట్స్ వై సాల్యుబిలిటీ is not directly proportional to pressure, especially in terms of solids and liquids, but in terms of gases solubility is directly proportional to pressure. For example, you know soda. In generally soda, they are pumping carbon dioxide water into the water. As the amount of pressure is increases, the rate of carbon dioxide entering into that water is also increases. Soda తీసుకున్నప్పుడు మీకు అర్థమవుతుంది. ఆ సోడా చేసే తను ఏం చేస్తాడు, దేర్ కంటిన్యూస్లీ పంప్ ద CO2 గ్యాస్. CO2 గ్యాస్ని పంప్ చేస్తూ ఉంటాడు. ఆ పంప్ చేసిన గ్యాస్ని వాటర్లోకి పోతూ ఉంటుంది. అంటే ఇక్కడ పంప్ చేసిన CO2 గ్యాస్, వాటర్ ఈజ్ అ సాల్వెంట్, CO2 గ్యాస్ ఈజ్ అ సొల్యూట్. హీ ఈస్ పంపింగ్ ద సొల్యూట్ ఇన్ టు ద సాల్వెంట్ వాటర్. ఇఫ్ యూ అప్లై మోర్ ప్రెషర్, there is more amount of solute, that is CO2, enters into the water. Dissolution అంటాం దీన్ని. అంటే in case of gases, the pressure is directly proportional to solubility. This is what pressure concept. Now we are moving on to nature of the solute and solvent. One more important thing, that is nature of solute and solvent. And just a minute. Students, I will be back. Okay students, welcome back. And now we already explained how the temperature will influences the stability and how the pressure also influences the stability and what are the exceptions in this. Now we are moving on to another important parameter, that is nature of solute and solvent. Solute and solvent. Nature of solute and nature of solvent. Depending upon the nature of solute and depending upon the nature of solvent, also the rate of solubility depends. How? I will explain. For example, take sugar plus water. This is one type. Now take naphthalene balls, naphthalene plus water. I am again taking as water. In these two examples, sugar is a solute. In this case, naphthalene balls are the solute in this case. If you observe the rate of solubility, the Bosque, for example, solubility 1 S1, solubility S2, sugar plus water S1, the rate of solubility, naphthalene plus water S2, rate of solubility. In the first case, the solubility is more, the rate of solubility is more because the solute is sugar. In the second case, the solubility is not that much fast as first step because the solute is naphthalene, it is more in, it is a very bulky material, it is very large in size compared to sugar. So, the rate of solute and solvent, the rate of solubility depending upon sugar, that means solute, solvent, water. So, based on the nature of solute, based on the nature of solvent, the rate of solubility depends. So, in the case of sugar plus water, the rate of solubility is A. In the case of this, the rate of solubility is B. Both are different. What makes the difference in this AB? The only difference is because of solute, because of nature of solute, because of differences that made in the solute composition, the rates are completely different. So, solubility also depends upon nature of solute and nature of solvent. So, this is all about solubility. Now, we are moving on to classification of solutions based around physical state, which is not at all explained in the last class. So far, this is already explained in the last class. Now, we are moving on to classification of solutions based on physical state. Classification, see, classification of solutions based on physical state. I am already said what is meant by physical state, because physical state in the sense we are physically seeing it, we are physically experiencing. For example, this is a pen. How can you say this is a pen? Because you are physically seeing the presence of pen. So, that is what. Similarly, classification of solutions based on physical state. That means by seeing the solution, you can classify the solution. Then that classification is known as classification of solutions based on physical state. Now, depending upon, see, important thing, you have to write it, depending upon physical state of physical state of solute and solvent, depending upon physical state of solute and solvent, depending upon physical state of solute and solvent, the solutions are classified into 9 types. Solutions are classified into 9 types, which are very, very, very important types. You have to know it at any cost. So, depending upon physical state of solute and solvent, the solutions are classified into 9 types. So, I will give you how the solutions are classified into 9 types. So, try to draw the diagram of it, and now the diagram is like this. First, nature of solution is the first column. The first column, nature of solution, is the nature of solution first in the first column. Next, solute type, a different type of solute will be there. One is solute, nature of solute. One is nature of solvent, and example. This is how we can usually classify the solutions depending upon their physical state of solute and solvent. Nature of solution, solute, solvent, examples. First, in the first column, serial number 1, nature of solution. First solution is type of solid solution. Solid solution. This is the first type of solution which is classified based on the physical state of solute and solvent. One is solid solution, in which solute is solid and solvent is solid, same. Solid solution is a solution in which solute is a solid, solvent is also a solid. Example for it is alloys. Examples are very important, students. It's very important. For example, bronze, brass, brass. These are the two examples which are called as alloys. Alloy in the sense, దీన్ని ఏమంటారంటే మిశ్రమం అంటారు. అంటే బ్రాస్ని, బాంజ్, ఇత్తడి, రాగి ఉంటుంది చూడండి, అది జనరల్గా ప్యూర్ ఫామ్ కాదు. ఒక రెండు మెటల్స్ యొక్క కాంపోజిషన్ మిక్స్ చేసినప్పుడు ఒక టైప్ ఆఫ్ మెటీరియల్ ప్రొడ్యూస్ అవుతుంది. అలా ప్రొడ్యూస్ అయిన మెటీరియల్నే మనం అల్లాయ్ అంటాం. అల్లాయ్లు ఏంటి, బ్రాంజ్ ఉంటాయి. ఇవన్నీ ఏంటి, డిఫరెంట్ టైప్స్ ఆఫ్ మెటల్స్ని కంబైన్ చేసినప్పుడు వచ్చేటువంటి ఒక టైప్ ఆఫ్ ప్రోడక్ట్స్ ఇది. సో ఇన్ విచ్ సొల్యూట్ కూడా సాలిడ్ స్టేట్లోనే ఉంటుంది, సాల్వెంట్ కూడా సాలిడ్ స్టేట్లో ఉంటుంది. అందుకే దిస్ ఈజ్ కాల్డ్ యాజ్ సాలిడ్ సొల్యూషన్. నెక్స్ట్ సెకండ్ వన్, solid liquid solution. Second one is solid liquid solution. In the case of solid liquid solutions, in the same manner, solute is also again solid. Solute is solid, but solvent is changing here, that is liquid. See, in solid liquid type of solution, the solute is solid but solvent is liquid. The best example is sugar water. We know that sugar plus water and salt plus water. These are the best examples for solid liquid solution. Why solute? Solid, that means sugar. Solvent, liquid, water. We are adding sugar into water, so it is called as sugar water solution. That is an example of solid liquid solution. Similarly, third one, solid liquid and solid gas. Solid gas. In this, solute is solid, solvent is gas. Solute is solid, solvent is gas. The best example for this is iodine and camphor. Solid gas, iodine. Example is iodine plus camphor. Solid gas solution best example ఏంటి, iodine plus camphor. iodine అంటే camphor అంటే ఏంటంటే కర్పూరం ఉంటుంది కదా, కర్పూరం. Usually we used to place the కర్పూరం in various temples or in our daily basis. కర్పూరం ఏమవుతుంది, కర్పూరం camphor can easily vaporize. అది ఈజీగా ఇట్లా వేపర్ అయిపోతుంది. సో బికాస్ ఆఫ్ ద సొల్యూట్ ఈజ్ సాలిడ్, సమ్ కైండ్ ఆఫ్ కెమికల్ ఉంటుంది దాంట్లో, సాలిడ్. సాల్వెంట్ ఏంటి, గ్యాస్ ఉంటుంది. గ్యాస్ సాల్వెంట్ ఉంటుంది కాబట్టి అది ఈజీగా వేపర్ అయిపోతుంది. సో క్యాంఫర్ ఈజ్ అన్ ఎగ్జాంపుల్ ఆఫ్ solid gas solution. That's why I am saying iodine plus camphor. So this is the three important topics based on the nature of solution. Now fourth one, now liquid system. Now liquid. In this case, solute and solvent both are liquids, like solid and solid. Liquid and liquid. Both are liquids. The best example for the liquid solution is alcohol in water. Usually we know that how the alcohol, the power of alcohol can be dissolved, or in the case of, for example, or కాన్సన్ట్రేషన్ ఉంటుంది కదా, మనం తీసుకునే ఆల్కహాల్, మనం పేరెంట్స్ తాగుతూ ఉంటారు కదా ఆల్కహాల్, దాని యొక్క కాన్సన్ట్రేషన్ తగ్గించడం కోసం మనం ఏం చేస్తాం, దే విల్ యూజువల్లీ యాడ్ వాటర్. సో ద వాటర్ ఈజ్ యాడెడ్ ఇన్ ఆర్డర్ టు రెడ్యూస్ ద కాన్సన్ట్రేషన్ ఆఫ్ ఆల్కహాల్. సో ఆల్కహాల్ సొల్యూషన్ ఈజ్ అన్ ఎగ్జాంపుల్ ఆఫ్ liquid solution in which alcohol is also a liquid, the water is also a liquid. So alcohol solution is an example for liquid system. Fifth one, liquid liquid solid system, in which liquid is a solute, solid is a solvent. Liquid is a solute and solid is a solvent. Example, see, liquid solid means in which liquid is a solute, solid is a solvent. The best example is amalgamation of iron, amalgamation of, not iron, sorry, mercury, amalgamation of mercury, that is Hg, hydrogen, mercury antam. Amalgamation of mercury ante entante, mercury, you know that whenever you observe thermometers, a kind of liquid will be present, that is also a metal. Amalgamation of mercury solution is an example for liquid solid solution. Now we are moving on to here, liquid solid completed, liquid completed. Now liquid gas solution, liquid gas solution, liquid gas, liquid gas solution. Liquid gas solution means in the solute is liquid, same, solvent is gas. Liquid gas solution, solute is liquid and solvent is gas. The best example is water vapor in clouds or water vapor in the air. We know that how the water vapor will be present in the air. Water vapor in air. See, water vapor in the air. If you observe the universe or if you observe the air around us, some kind of moisture in the padunu ante konjam tema untadi, tema humidity antam danni. So certain amount of humidity is also present in this air. In the case, air is a medium, that is a solvent, in which the water droplets or moisture content it is dissolved. So in this, solute means water vapor drops, water drops. Gas means air. So this is called as water vapor in air, which is an example of liquid gas system. So this is what liquid gas system. Now coming to gas and gas solid and gas liquid. In this, solute is gas, solvent is also gas. In this case, solute is gas, solvent is solid. In this case, solute is gas, solvent is liquid. So these are mainly in all these cases. In these three cases, the solute is common, that is gas, but the solvents are completely different. For example, for gas, for example, mixture of gases, simply air or atmosphere. For example, you observe air, it contains oxygen, nitrogen, helium, different kinds of gases, nitrogen, oxygen, fluorine and chlorine gas, and everything will be there in the air or atmosphere. So it is an example of gas because solute, solvent both are gases. So it is an example for gas system, that is called a mixture of air. Now we are moving on to gas solid. Gas solid in the sense, example is H2 is absorbed by palladium, PD, palladium metal, this is metal. See, once clearly observe this, here solute is gas, solvent is solid. That means this gas is a solute which is absorbed in the solid. H2 is the gas which is absorbed by PD metal. Palladium ane metal to hydrogen bind chesinapudu some amount of hydrogen can get absorbed by palladium. So then the resultant product is an example of gas solid type of solution. అంటే ఏంటి ఇప్పుడు అర్థమైంది కదా, H2 ఎప్పుడైతే palladium అనే మెటల్ తో అబ్జార్బ్ చేయబడుతుందో అప్పుడు ఆ palladium మెటల్ ప్లస్ H2 ఆ కాంపోజిషన్ ఉంటుంది కదా, అలా ఉన్నటువంటి కాంపోజిషన్ ఆ సొల్యూషన్ ఏదైతే ఉంటుందో that solution is an example of gas solid system. Now gas liquid, that is aeration of drinks, very familiar, I think you know this. Aeration of cool drinks, simply like soda, thumbs up and everything. See, in this For example, I already explained this example in previously, that is gas and liquid. Gas is CO2 in the case of soda, or carbonated drinks antam manam. When you observe on the labeling of thumbs up or Sprite, you will observe the carbonated beverages. Carbonated beverages in the sense it contains carbon dioxide. అంటే మీరు థమ్స్ అప్ అవన్నీ చూసినప్పుడు దాంట్లో నురగ వస్తుంది, ఫ్రోత్ అంటాం దాన్ని. ఆ నురగ రావడానికి కారణం ఏంటి? దాంట్లో కార్బన్ డైఆక్సైడ్ ఉంటుంది. అంటే వారు మ్యానుఫ్యాక్చరర్ ఎవరైతే ఉంటారో దే ఆర్ పంప్ ద కార్బన్ డైఆక్సైడ్ ఇన్ టు ద సొల్యూషన్ ఆఫ్ ద థమ్స్ అప్. అలా ఉండడం వల్లనే దాన్ని కార్బనేటెడ్ బీవరేజెస్ అనే ట్యాగ్ ఇస్తారన్నమాట దానికి. సిమిలర్లీ గ్యాస్ లిక్విడ్ సొల్యూషన్ ఈజ్ ఎగ్జాంపుల్ విచ్ ఇస్ ఎగ్జాంపుల్ ఫర్ ఎరేషన్ ఆఫ్ కూల్ డ్రింక్స్. అంటే కూల్ డ్రింక్స్ ఆర్ ద బెస్ట్ ఎగ్జాంపుల్స్ ఫర్ gas, liquid type of solutions. These are all the different kinds of solutions which are basically dependent upon physical state of solute and solvent. Solute to solvent ఏ స్టేట్ ఆఫ్ మ్యాటర్లో ఉన్నాయి అన్న దాన్ని బేస్ చేసుకొని 9 టైప్స్గా క్లాసిఫై చేసింది. ఆల్రెడీ వీ సీన్ దట్ సాలిడ్ సాలిడ్, సాలిడ్ లిక్విడ్, సాలిడ్ గ్యాస్, లిక్విడ్ లిక్విడ్, లిక్విడ్ సాలిడ్, లిక్విడ్ గ్యాస్, గ్యాస్ గ్యాస్, gas solid, gas liquid. These are the 9 types which are dependent on the physical state of solute and solvent. This is how the solutions are basically classified. Now we are moving on to properties of solutions, also very important. Now I am writing properties of solutions. Properties of solutions. I'm writing what are the properties of solution. So far we have discussed what is meant by solution, what are the components of solutions, what are the types of solutions, what are the classification based on physical state of solute and solvent, and the examples that respond to them. Now we are moving on to properties of solution. What are the properties of solution? We already know that solution is an example of first property. Solutions are homogeneous mixtures. This is the first property of solutions. Solutions are, it is a homogeneous in nature. Homogeneous in nature. First property of solutions వచ్చేసి it is homogeneous in nature. Homogeneous అంటే ఆల్రెడీ చెప్పాను నేను, in which all the particles are evenly distributed, అన్ని ఈక్వల్గా స్ప్రెడ్ అయి ఉంటాయి కాబట్టి దాని homogeneous. Maximum every solution is homogeneous in nature. Second one, the particle size is always less than 1 nanometer. Less than 1 nanometer. The second property of solution is, we know that solution contain different components. Each and every component contains small minute particles. So if the particle size is less than 1 nanometer, then it is considered as solution. So by the explanation we came to understand that the particle size within the solution is always less than 1 nanometer. This is the one important. And third one, the particles are not easily visible to our eye. అంటే ఒక సొల్యూషన్ ఫామ్ అయిన తర్వాత, ఫర్ ఎగ్జాంపుల్ మిల్క్ని వాటర్ని యాడ్ చేసాం, అవి యాడ్ అయిన తర్వాత వాటిని మనం డిఫరెన్షియేట్ చేయలేం, ఎందుకంటే అవి సొల్యూషన్స్. వీ కెనాట్ సీ ద కాంపోనెంట్స్ ఇన్ సపరేట్ ఆఫ్టర్ ద ఫార్మేషన్ ఆఫ్ సొల్యూషన్. సో వీ can't see the particles. Can't see the particles with our naked eye. So this is another important parameter. And fourth property is, the components of the solution cannot be separated by normal filtration. Generally మన వాటర్ తాగుతుంటాం. in the household generally we have purifiers, water purifiers. Water purifiers ఏం జరుగుతుంది, when the water in the case of water purifier, all the different types of contaminants or pollutants in the water can get separated from the water. At the end we get pure water which is portable water అంటాం. దాన్ని పోర్టబుల్ వాటర్ అంటే దే కెన్ ఏబుల్ టు డ్రింక్, మనం డ్రింక్ చేయడానికి అనువైన వాటర్. సిమిలర్లీ అయితే అక్కడ మనం ఏం చేస్తున్నాం, సాలిడ్ పార్టికల్స్ని వాటర్ నుండి వేరు చేస్తున్నాం, పొల్యూటెంట్స్ని. సో దే క్యాన్ బి సపరేటెడ్ బై జనరల్ ఫిల్టరేషన్ ఆర్ కెమికల్ ఫిల్టరేషన్. బట్ ద పార్టికల్స్ విత్ ఇన్ ద సొల్యూషన్స్ కాంట్ బి సపరేటెడ్ బై జనరల్ ఫిల్టరేషన్. ఫిల్టరేషన్ అనే టెక్నిక్ని వాడి సొల్యూషన్లో ఉన్న కాంపోనెంట్స్ని మనం సపరేట్ చేయలేము. ఇట్ ఈస్ హైలీ ఇంపాసిబుల్ టు సపరేట్ ద కాంపోనెంట్స్ ఆఫ్ సొల్యూషన్స్ by normal filtration. Fourth one is, it is impossible to separate the components of the solution of the solution it is impossible to separate the components of the solution by normal filtration. See, these are all the four important properties of solution. First property, it is a homogeneous in nature. Second property, particle size is always less than 1 nanometer. Third one is, we cannot see the particles with our naked eye. Fourth one is, it is impossible to separate the components of solution based on normal filtration technique. Special kind of apparatus is there. We can know what is the special kind of apparatus generally used to separate the components of solutions in previous year's questions. I am going to make you understand that. And this is the properties of solutions. Now we are moving on to very important things, especially in the case of solution, that is atomic weight, molecular weight and equivalent weight. Now I am going to explain you what is meant by atomic weight and what is meant by molecular weight and everything. First, atomic weight. Atomic weight. You generally come across atomic weight. What is meant by atomic weight? What is meant by atomic mass? For example, this is a pen. Pen is an example for one compound or any kind of one substance. Already in the first class itself, I have clearly explained what is meant by atom, what is meant by molecule, what is meant by compound and what is meant by matter. So this is an example of matter. It is made up of many atoms. లక్షల కొద్ది ఆటమ్స్ అన్నీ కలిసి ఒక మ్యాటర్ని ఫామ్ చేస్తాయి. సో మిలియన్ నెంబర్ ఆఫ్ ఆటమ్స్ కెన్ ఫామ్ వన్ మ్యాటర్. సో ఫర్ ఎగ్జాంపుల్, ఇఫ్ దిస్ పెన్ ఈజ్ ద కాంబినేషన్ ఆఫ్ మెనీ ఆటమ్స్, మెనీ స్మాల్ ఆటమ్స్, ఇఫ్ ద మాస్ ఆఫ్ వన్ సింగిల్ ఆటమ్, ఈ కాంపౌండ్లో ఉన్న అన్ని ఆటమ్స్లలో ఇఫ్ ఒక ఆటమ్ని మాస్, ఒక ఆటమ్ యొక్క బరువుని మనం మెజర్ చేయగలిగితే, దట్ మాస్ ఈజ్ కాల్డ్ యాజ్ అటామిక్ వెయిట్. Atomic weight is now defined as the mass of single atom within the molecule or within the matter. That is called as atomic weight. So the definition is as follows. Atomic weight in the sense, it is defined as the mass of single atom or individual atom, single or individual atom of molecule, simply molecule of molecule. This is termed as atomic weight or atomic mass. Atomic weight or atomic mass. Atomic weight or atomic mass. Generally, the atomic weight is denoted by the capital letter A alphabet. capital alpha A. A is a letter which is generally denoted in order to explain the atomic weight. And for example, I will make you understand the concept of atomic weight in very simplistic terminology. That is, for example, these are all atoms. All atoms. This is a molecule. Simply, these small dots are atoms. This big square is the molecule. For example, if in order to find out the total mass of this compound or this molecule, we have to know the mass of this atom, the mass of this atom, the mass of this atom, this atom, this atom, this atom. If the mass of this one single atom, this single atom, mass of this single atom is called as atomic weight. Single atom. Single atom is called as atomic weight. Similarly, this atom, it has some atomic weight, this atom has some atomic weight. And again, one more important and interesting phenomenon is that atomic weight is the sum of masses of 3 subatomic particles. In the first class, I already said, when you observe the structure of atom, there are 3 types of subatomic particles: proton, electron and neutron. Electron has some mass, neutron has some mass, proton also has some mass. So the masses of 3 subatomic particles is equal to mass of one atom. See, this is also a very important concept. Try to remember this. Mass of electron plus neutron plus proton. The masses of all these 3 components gives rise to mass of an atom. Mass of an atom. I think you can have an idea about this. Now you are familiar with this atomic weight. Atomic weight is denoted by A. Atomic weight is defined as the mass of individual atom within the molecule. The group of all the molecules combined together to give molecular weight. I will explain in the next thing. For example, this is a molecule. It contains small dots are atoms. If we take the mass of one single atom, this is one dot, it is called as mass of single atom. Then mass of atom is the sense it is a sum of masses of 3 subatomic particles, namely proton, neutron, electron. This is called as mass of an atom. This is termed as atomic weight. Now we are moving on to molecular weight. See, first atomic weight completed. Now we are moving on to molecular weight. Molecular weight. Molecular weight. We are moving on to molecular weight. What is meant by molecular weight? We know that what is atomic weight? Single atom యొక్క weight. For example, this is the molecule. It contains many atoms. The sum of all the atoms, ఒక molecule లో ఉన్న atoms యొక్క అన్ని weight ని కలిపి దాన్ని molecular weight అంటే sum of atomic weights అని అర్థం. ఒకే atom అయితే atomic weight, అన్ని atoms అయితే molecular weight. That means it is defined as mass of entire molecule. ఒక molecule యొక్క పూర్తి mass of entire molecule. Mass of entire molecule. The mass of entire molecule in the sense sum of atoms. ఒక molecule యొక్క మొత్తం weight అంటే ఏంటి? It is nothing but sum of all the atoms in that molecule. ఒక molecule లో ఉన్నటువంటి atoms అన్ని యొక్క mass ని కలిపితేనే అది molecule weight అవుతుంది. So it is also called as sum of atomic weights. Sum of atomic weights. Sum of atomic weight. Then this is denoted as generally as M. Molecular weight can be, or molecular mass is also called as weight. For example, molecular mass can be calculated by a formula called as number of atoms by atomic weight. Number of atoms by atomic weight. Number of atoms by atomic weight. Number of atoms by atomic weight gives rise to the concept called as molecular weight. Molecular weight. Number of atoms by atomic weight is termed as molecular weight, which is denoted by the letter M. So this is all about molecular weight. Now we are moving on to another concept, that is equivalent weight. What is meant by equivalent weight? Now third, this atomic weight completed, molecular weight completed. Now we are discussing about equivalent weight. What is equivalent weight? Equivalent weight. Equivalent weight. What is meant by equivalent weight? Equivalent weight is a special case. Equivalent weight is the another form of molecular weight. Molecular weight ki inko form idi. So equivalent weight is one of the form of molecular weight, but in the case the mass of the substance are usually expressed in the terms of grams. అంటే జనరల్గా మాలిక్యులర్ వెయిట్ అంటే ఏంటి, ఆటమ్స్ అంత వెయిట్ కలిపితే అది మాలిక్యులర్ వెయిట్ అయిపోతుంది. ఈక్వివాలెంట్ వెయిట్ అంటే ఏంటంటే ఇట్ ఈస్ ఆల్సో మాలిక్యులర్ వెయిట్, బట్ ద మాస్ ఆఫ్ ద మాలిక్యూల్ ఆర్ ద మాస్ ఆఫ్ ద టోటల్ ఆటమ్స్ ఆర్ ఎక్స్ప్రెస్డ్ ఇన్ టర్మ్స్ ఆఫ్ గ్రామ్స్. ఒకవేళ దాన్ని గ్రామ్స్లో కనుక మెజర్ చేస్తే దట్ ఈస్ కాల్డ్ ఈక్వివాలెంట్ వెయిట్. ద ఈక్వివాలెంట్ వెయిట్ ఈస్ డిఫైన్డ్ యాజ్ if weight of the molecule is expressed in terms of grams, which is equal to 8 grams of oxygen O, I am making O, oxygen, and 1 gram of hydrogen. See, equivalent weight means it is also a molecular weight, but here the molecular weight is expressed in terms of grams. So this equivalent weight is always equal to 8 grams of oxygen and 1 gram of hydrogen. This is what equivalent weight. It is generally denoted as E, capital E. Now I will give you one example, very important example. From that example I will make you understand what is meant by mole concept. I am going to give you one important example, that is I will give you a small example. Based on that example, by understanding that example, you will get an idea about one more concept that is called as mole concept. That example is, first I will make you understand the examples first. For example, very important example, try to note it out. For example, for examples, there is a solution whose volume is 500 ml. Volume of solution is 500 ml. Let us consider volume of solution is 500 ml. Okay, solution యొక్క volume 500 ml ఉంది. Mass of, for example, mass of, this is a given mass. వాళ్ళు ఇచ్చిన మాస్ ఎంత, given mass of K2CO3. ఇది ఒక కాంపౌండ్, పొటాషియం కార్బోనేట్. K2CO3 mass is equal to 20.7 grams. This is వరకు మీకు అర్థం కావడం కోసం మంచి ఎగ్జాంపుల్స్ ఇస్తున్నా. So you just be focused on these examples. If you understand what are the various terms what I mentioned in this question, you can definitely understand what is meant by another concept called as mole concept. So mass of potassium carbonate is 20.7. Now we already know that molecular weight of K2CO3. Molecular weight in the sense atoms, sum of atomic weights, that means 2 K2, that means 2 potassium atoms, 1 carbon atoms, 3 oxygen atom, all the sum gives rise to 138. 138 grams is the molecular weight. Molecular weight of K2CO3 is 138 grams. Now we can, from this we can calculate or we can define another important concept, that is mole concept. Mole is equal to general mole. See, from this I am explaining mole concept, and in the next slide also it is also there. That is, so I think you know this, 500 ml 20.7 138 grams. Please make it, note it down. And next, the mole concept. The mole concept in the sense, in the mole concept, moles generally denoted by the letter small n. Moles in the sense small n. Small n is equal to small m by capital M. This is a formula which is very important formula in entire field of chemistry. So the moles is equal to small m by capital M, where the small m is equal to molar mass. Molar mass. For capital M is denoted as molecular mass or molecular weight. Molecular mass or molecular weight. Molecular mass or molecular weight. So molecular mass or molecular weight is a capital M. So number of moles n is equal to small m by capital M. Now from the above example, what I given that K2CO3, from that n is equal to 20.7 grams. I already said small m means molecular mass, that is given mass enta K2CO3 20.7 grams by molecular weight enta 138 grams. 138 grams. N is equal to number of moles of K2CO3 can be calculated by 20.7 is the molar mass, 138 is the molecular mass. Molar mass by molecular mass, which is equal to approximately 0.15 moles. 0.15 moles. So in this way the number of moles can be calculated by a concept called as mole concept, which is denoted by small n. The formula is small m by capital M. Small m is molar mass and capital M is the molecular mass. This is what mole. Now from the concept of mole, one more important concept can also be discussed. From the concept of mole, one more concept can also be discussed. That concept is called as molarity and normality. Now we are moving on to molarity and normality. For example, molarity means, simply first we are going to discuss about molarity. Molarity definition. Molarity means it is defined as number of moles of solute in 1 liter of solution. That means molarity is generally defined as, molarity means capital M is defined as number of moles, that means N, by volume of solute, number of moles of solute, number of moles of solute by volume in 1 liter of solvent or one solution. See, molarity is defined as the number of moles of solute is divided by volume of solution in 1 liter. That is called as molarity. Molarity is defined as it is defined as number of solute, number of moles of solute in 1 liter of solution. Very important, this is 1 liter. I'm rounding off 1 liter of solution. 1 liter of solution. 1 liter of solution. This is termed as molarity. Then molarity is formula is number of moles of solute by volume in 1 liter of solution. This is called as molarity. Concept of this is molarity. Now from the above example, what is the molarity of K2CO3? In the first example I said from potassium carbonate, we have clearly explained what is meant by mole concept, what are the number of moles. Now from that same examples, we can also calculate what is meant by molarity. Molarity is equal to molarity of the, for example, K2CO3, previous example. Molarity is equal to 0.15. In the sense, moles, we have already calculated N value in the previous example, that is 0.15. Number of moles by volume of solution, in the sense, here 500 ml. Volume means, first I said, number of moles by 1 liter of solution. There, what is the volume of solution? I said 500 ml in the K2CO3. If 500 ml is converted into liter, it is termed as 0.5. 0.5. 0.15 by 0.5 is equal to approximately 0.3 m. It is very important to mention capital M here. It indicates 0.3 m, which is nothing but 0.3 m concentration of K2CO3 in 500 ml of water. So this is how the molarity can be calculated. So this is what concept of molarity. Now we are moving on to concept of normality. We are moving on to concept of normality. Normality is simply, it is also molarity, but the only difference is, it is defined as normality N is equal to gram equivalent weight, gram, here not moles, see, gram equivalent weight of solute, gram equivalent weight of solute by divided by 1 volume in 1 liter, same as molarity of solution. Normality is equal to, it is defined as gram equivalent weight of solute by volume in 1 liter of solution. This is called as normality. Now the normality can be also classified as gram equivalent. How to get the gram equivalent weight? The formula used to calculate, we know in the first molarity N by V. N we already know, the small m by capital M is equal to N. Similarly, N is equal to gram equivalent weight by V. How the gram equivalent weight can be calculated? Gram equivalent weight is also can be divided as weight by equivalent weight. Weight by equivalent weight into 1000 by volume in ml. This is a formula. Equivalent weight is equal to, and normality is equal to weight by equivalent weight into 1000 by V in ml. Now, in order to know the equivalent weight now, equivalent weight is equal to molar mass, that is how much amount of sample is given, molar mass by number of moles. These are very, very important concepts, try to remember it. This is equivalent weight, formula for equivalent. Equivalent weight calculate cheyadaniki molar mass by N, normality calculate cheyadaniki weight by equivalent weight into 1000 by V in ml. These are the very important concepts in this. So these are the things which are going to discuss here. And now we are moving on to numerical. Numerical ante entante, how much extent we are capable of solving the problems on that concept. ఒక కాన్సెప్ట్ మనకు వచ్చినప్పుడు దాన్ని ఎలా మనం ట్యాకిల్ చేయగలుగుతున్నాం అంటే ఒక ప్రాబ్లం ఇచ్చినప్పుడు కాన్సెప్ట్ అర్థమైతే ప్రాబ్లమ్స్ ఈజీగా మనం సాల్వ్ చేయగలం. ఇట్ ఈస్ వెరీ ఈజీ టు సాల్వ్ ద వేరియస్ ప్రాబ్లమ్స్ when we have an idea about concept. Without having proper concept, then there is nothing else happen to solve that question. Now numerical problems in the ECET exam, especially in the ECET point of view, the numericals are very important for mole, molarity and normality. The first numerical I will give, and these are the examples which are prepared myself, which are very very useful to you, especially to get maximum marks in these topics. First numerical is about mole concept. Example 1, question 1. Find the number of, this is the question, find the number of moles of H2 hydrogen H2 in 10 grams of H2 question. So this is the first question, that is deal with mole. From this question you can get an idea about how to calculate or how to solve the questions which are based on mole concept. The question is, find the number of moles of H2 in 10 grams of H2. 10 grams of H2 లో ఎన్ని moles of hydrogens ఉన్నాయి అనేది క్వశ్చన్. Now we already know that. What is the formula of mole? First we have to write like this. Given mass is 10 grams. Given mass is equal to 10 grams. Given mass is 10 grams. Given mass is 10 grams, and now given mass is 10 grams. We know that molecular mass of hydrogen is equal to 2, because hydrogen 2, one hydrogen means 1 atomic weight, 2 hydrogen means 2. So the molecular mass is equal to 2 grams. We know we have molar mass and we have already has molecular mass. Now we know the formula for calculation of number of moles, that is n is equal to small m by capital M. This is a formula. We know this. N is equal to small m by capital M. We already studied what is the formula of mole. Now small m is this, capital M is this. Then 10 by 2. 2 ones are, 2 5s are. Now the number of moles is 5 moles. The answer is 5 moles. Though find the number of moles of H2 in 10 grams of H2 means 10 గ్రాముల హైడ్రోజన్లో ఎన్ని మోల్స్ ఆఫ్ హైడ్రోజన్స్ ఉన్నాయంటే 5 moles of 5 moles plus 5 moles 10 moles is equal to 10 grams of H2. This is one of the very important question, especially in terms of mole concept. Next question is in the same, so try to note down it. Second question number 2. How many, same is, this is also for mole, how many moles are there in 52 grams of helium. Now helium, see the question is, how many moles are there in 52 grams of helium? 52 grams of helium లో ఎన్ని moles ఉన్నాయని అడుగుతున్నాడు ఇక్కడ క్వశ్చన్. Now we know that given molar mass, how much? 52 grams. Molecular mass in the sense molecular weight of helium is equal to 4. Helium weight is 4 grams. Now for these kind of questions we can also write like this. We we can write like this. For example, 4 grams. For example, 4 grams is equal to 1 mole. I am assuming it. నేను అనుకుంటున్నా 4 grams అనేది 1 మోల్కి ఈక్వల్ అయింది అనుకుందాం. ఇప్పుడు 1 gram అంటే ఎంత? క్వశ్చన్ మార్క్. 4 grams of helium is equal to 1 mole of helium. 1 gram of helium is equal to how much? Then it is gives rise to 1 by 4 moles. 4 grams of helium contains 1 mole. 1 gram contains 1 by 4 moles. Now we know 52 grams. So we want how much 52 grams contains how many number of moles. Now 1 by 4 into 52. Then it gives rise to 52 by 4, that is 13 moles. See, how many moles are there in 52 grams of helium? 52 గ్రాముల హీలియంలో ఎంత హీలియం మోల్స్ ఉన్నాయి మనకు తెలిసింది ఏంటి? ఆల్రెడీ వెయిట్ ఇచ్చిండు, దట్ ఈస్ మోలార్ మాస్. We know already molecular weight of helium, that is 4 grams. We can write 4 grams contains 1 mole, 1 gram contains 1 by 4 mole, 52 contains 52 into 1 by 4, that is 13 moles. This is how we can calculate number of moles. Now we are moving on to next. Numerical is based on molarity concept. Molarity is also very important. Now numericals on molarity. Molarity. Now calculate the molarity of, this is a question, calculate the molarity of calculate the molarity of 30 grams of cobalt nitrate. Cobalt means CO, NO3 2 taken twice plus 6H2. This is a compound. Cobalt nitrate in 4.3 liter of solution. See, the important things are, you have to clearly focus that given 32 grams of cobalt nitrate 6H2 compound. How much volume? 4.3 liters of solution. Now we have to calculate molarity. We know that molarity is equal to, this is a solution, molarity is equal to N by V, number of moles by volume in liter of solution. Now we know that what is the given mass. Now we should calculate N. First we have to calculate N, then V. N is equal to small m by capital M. Small m means given mass, that is 30. We don't know what is M. M, the molecular weight of cobalt nitrate plus 6H2O, when we sum of all the cobalt, అన్నీ మనం సమ్ చేసినప్పుడు వచ్చే molecular weight వచ్చేసి approximately 291. Molecular weight is 291, molar mass is 30. Then N is equal to 0.103 moles. After calculating 30 by 291, we can get as 0.103 moles. మనకి ఇప్పుడు ఏమొచ్చింది? 0.103 moles వచ్చింది. Now we have to calculate molarity. We know now, we clearly know మనకు మోల్స్ ఏంటో తెలిసింది. వాల్యూమ్ ఎంత? 4.3 liters. Now N is equal to 4. Now for example, N is equal to 0.103 by value means 4.3. After calculation, it is given as, we can get as 0.023 moles molarity. M, 0.023 molarity. Calculate the molarity of 30 grams of cobalt nitrate 6H2O in 4.3 liter of solution. Molarity is equal to N by capital V. We know the N is equal to small m by capital M. Given small m is equal to 30 grams and capital M means 291, sum of all these atoms in this compound. Now finally the number of moles is 0.103 moles. Finally 0.103 by 4.3, that is volume of solution, we can get as 0.023 molarity. The molarity of the solution is 0.023. This is the one of the very important concept. Next, another problem again based on the molarity, that is question calculate the molarity of 2.3 grams of KMNO4. Calculate the molarity of 2.3 grams of KMNO4 dissolved in 500 ml of water of H2O. Question, see the question now. First of all, the basic thing you have to remember is first try to read the question many times. You will get an idea what is actually asking in the question. Calculate the molarity of 2.3 grams of KMNO4 dissolved in 500 ml of water. Now, we know the formula for molarity. Molarity is equal to number of moles by volume. Now, first we have to calculate N. N is equal to molar mass by molecular mass, that is 2.3 by molecular mass of KMNO4 is 158.034. This is the molecular mass of KMNO4. Then N is equal to 0.01 moles. 0.01 moles. Now N we got N of, that is 0.01 by value means 500 ml. It gives rise to 0.0002 m molarity. 02 molarity. This is how we can calculate molarity. Now we are moving on to concept of numerical problems, that is normality. Now normality. Now normality. Normality in the sense we already discussed what is the definition of normality. Capital N is equal to gram equivalent weight by volume in liters. It can also written as weight by molecular weight by molecular weight into 1000 by V in liters. The question is, this is a basic. Now the question is, this is based on normality. Normality question. Calculate the normality of calculate the normality of 0.321 grams of 0.321 grams of Na2CO3 in 250 ml of solution. In 250 ml of solution. Calculate the normality of 0.321 grams of Na2CO3 in 250 ml of solution. Now N is equal to solution. N is equal to, we know that number of gram equivalent weight into 1000. In the, previously I am given the definition for normality. If we simplify the definition or the formula used to calculate normality, we can get this formula, that is number of gram equivalent weight into 1000. Now we know that number of gram equivalent weight is 0.321 grams. 0.321 grams into 1000, and also the volume is 250. See, 0.31 is the number of gram equivalent weight which is given here. 1000 is the in the formula, volume also 250. Then it is given as 0.024 normality. 0.024 normality is the one for the normality. This is how we can calculate the normality of given solution. This is all about normality, and this is all about solutions, components of solutions, properties of solution, classifications of solution, solubility, types of solubility, factors that influences the rate of solubility, and now concept of atomic weight, concept of molecular weight, concept of equivalent weight, normality, molarity are completed now. I think you get an idea about everything about this. Now we are moving on to an important topic, that is colloids. So this is all about solutions. Now we are moving on to colloids. We are moving on to colloids. Just a minute. We are moving on to colloids. We are moving on to now we are moving on to next topic, that is colloids. Solutions and colloids. Now we are moving on to colloids. Solutions and colloids are part and parcel. That means one cannot there without other. అంటే ఒకటి లేని ఇంకోటి ఉండదు. అంటే solutions and colloids, both colloids and solutions are discussed together. ఎప్పుడు కూడా solutions colloids తో చెప్తూనే ఉంటారు. Solution లేకుండా colloid ఉండదు, colloid లేకుండా solution ఉండదు. Both solutions and colloids are together taught by any lecture of chemistry. Now we are moving on to colloids. What are colloids? First of all, definition. Definition of colloids. Definition of colloids. What is meant by colloid? Colloid means colloid is an example of heterogeneous mixture. Solution is an example of homogeneous mixture, but it is an example of heterogeneous mixture. It is an example of heterogeneous mixture. Heterogeneous mixture. It is an example of heterogeneous mixture. Colloids are the examples of heterogeneous mixture. Heterogeneous mixture means, I already said, homogeneous, heterogeneous. Homogeneous means components are evenly distributed. Heterogeneous means components are unevenly distributed or not distributed equally. So that is an example for heterogeneous mixture. For example, colloids. For example, this is A and B. A is the one component, B is the other component. When these A and B are combined together in a particular kind of beaker, A component and B component are not distributed equally or evenly in the beaker. If that is the case, then that kind of mixtures are called as heterogeneous mixture. Colloids are such kind of examples. Then AB is an example of colloid. AB is an example of colloid. And in the terms of colloid, in the solutions, all the particles are completely bind together and they are dissolved together. But in colloids, always one component is suspended in another component. అంటే ఒక కాంపోనెంట్ అనేది ఇంకో కాంపోనెంట్ ఎప్పుడు కూడా ఇట్లా ఫ్లోట్ అవుతూ ఉంటుంది. దిట్ ఈస్ కాల్డ్ as suspension. One component or particles of one component always be suspended in other component. This is called as dispersion of molecules అంటాం దీన్ని. అంటే ఏంటంటే A అనే కాంపోనెంట్ ఆల్వేస్ B అనే కాంపోనెంట్ ఇట్లా ఫ్లోట్ అవుతూ ఉంటాయి. The components of A will always float in the component of B because they are not evenly distributed. That is why this is called as heterogeneous mixture. Now, in the case of solutions, we said that the particle size is less than 1 nanometers. Similarly, colloids also possess particles whose particle size is approximately equal to 1 to 1000 nanometers. Particle size. Particles are generally insoluble because they float. Particles are generally insoluble. Particles are generally insoluble because float or suspension. Floats or suspends. Floats or suspend. Particles are generally insoluble, floats or suspends, and particle size is approximately generally 1 to in the range of 1 to 1000 nanometers. The range of 1 to 1000 nanometers, which is equal to 10 to the power of minus 9 meters. Colloids. The particle size of colloid is 1 to 1000 nanometers. It is also equal to 10 to the power of minus 9 meter. This is the definition of colloid, the particle size of colloid. And one more interesting thing about colloids is colloidal solutions are also called as salts. Salts in the sense colloidal solutions are also called as salts. Very, very important term. Colloidal solutions are also called as salts. One of the important characteristic feature, one is a remarkable and striking feature of colloids is colloidal solutions show a phenomenon called as Tyndall effect. It shows a phenomenon called as Tyndall effect. Tyndall, very, very important. I think you are familiar with this effect also. Tyndall effect. Tyndall effect is a phenomenon that is only exhibited by the particles of colloids. For example, what is meant by Tyndall effect? I will give you simple example. This is the beaker. This is a colloidal solution in which these are the particles which are suspended like this. When sunlight is passing on it, when sunlight passes on it, when you allow the sunlight to pass through these particles, then the sunlight will be scattered like this. Like this. When the sunlight is allowed to pass, this is the sunlight, like this it coming, the particles are suspended within the colloidal solution. This sunlight is getting scattered. When this light comes contact with these particles, the light will be scattered in multi-directional, like this, randomly it is scattered. Scattering ఏంటంటే ఇలా స్ప్లిట్ అవుతాయి లైట్ రేస్ అన్నీ కూడా. దీన్ని ఏమంటారంటే ఈ ఫెనామినన్ ఏమంటారంటే టిండాల్ ఎఫెక్ట్ అంటారు. ఇదే టిండాల్ ఎఫెక్ట్ సొల్యూషన్స్ జరగదు, ఎందుకంటే దేర్ ఆర్ నో సస్పెండెడ్ పార్టికల్ in terms of solutions. But in the case of colloids, there are suspended particles. Because of that reason, the colloidal particles gives Tyndall effect on allowing of sunlight into this. So this is called as Tyndall effect. Now, types of colloids. Before going to types of colloids, I will explain one other type of colloid that is very, very important. Before that, types of colloids based on physical state. Very, very important. This is types of colloids. Types of colloids. Types of colloids based on physical state. And one more thing before going to the types of colloids, I missed one topic, that is colloids. In the solution there are two components, solute and solvent. Similarly, the colloids are also combination of two components. That components are dispersed phase and dispersed media. Dispersion phase, dispersion phase, dispersion phase, and very, very important, these are the two components in the colloids. In the case of solutions, solute, solvent. In the case of colloids, dispersion phase and dispersion media. Dispersion medium. Dispersion phase and dispersion medium are the two important components in colloids. Dispersion phase is always in smaller proportions, in low proportions or low concentrations, low proportions. Dispersed medium is always in larger amounts or larger proportions. In low proportions and larger proportions, dispersed phase and dispersed media. I will make you understand how that is. Now, types of colloids based on physical state. Now, based on the type of physical state of dispersed phase and dispersed medium, the colloids are mainly classified into three types. First type is solid colloids or solid solutions or solid salts. First is solid salts. In this, solid salts are solid colloids. Classification of colloids based on physical state. The first classification is solid salts or solid solutions or solid colloids. Solid colloids are the colloids in which both the dispersed phase, the dispersed medium are solids. In the case, I am writing dispersed phase as dP, dispersed medium as dm. Dispersed phase is a solid. In this case, physical state I am saying that. Dispersed medium also solid. These kind of colloids are called as solid salts. The best example is gemstones. I think you are familiar with the gemstones. Gemstones, మనం రత్నాలు అంటాం చూడండి, అక్కడక్కడ మనం టెంపుల్స్లో చూస్తూ ఉంటాం gemstones. That gemstones is the best example for solid salts in which both the dispersed phase and dispersed medium are solids. Next example is aerosols. Second example is aerosols. Very important term, it is aerosol, in which aerosol in the sense, aerosol is also type of colloid, but the physical state of dispersed phase and dispersed medium are different. In the aerosol, dispersed medium is air around us. Dispersed medium dP is gas, that is air. Dispersed medium is gas. Dispersed phase dP is equal to vapor or water. Vapor. Dispersed medium is gas, dispersed phase is vapor. Example, clouds. You know clouds? In clouds, there is the water vapor and there is air. So this is an example for aerosols. Similarly, dust particles. Dust is the small pollutants in the air. Similarly, smoke, cigarette smoke. These are the three examples for aerosols. Now, third case. This is first type. This is second type, and third type is emulsions. Very important. I think this is very important concept for exam point of view for your ECET. For ECET, emulsion concept is very easy and very important also. Emulsions means these are the special colloids. Special colloids. These are the special colloids in which both dispersion phase and dispersion medium are liquids. Liquid. Dispersed phase and dispersed medium both are liquids. Special colloids, emulsions. Again, the emulsions are also classified into two types. One type, two types. Oil in water type and water in oil type. Don't be confused with this. These are two categories of emulsions. Oil in water type and water in oil type. Example for this is milk. Example for this is creams or jellies. Examples. Emulsions, special colloids in which both dispersed phase and dispersed medium are liquids. And again these emulsions are two types, oil in water type and water in oil type. For example, milk. Milk contains two components. One is water plus fat. Water and fat. Water in combination with fat, that is protein, milk protein. Fat, here the fat is the dispersed medium, where water is the dispersed phase. Dispersed, I am highlighting this C. Water is the dispersed phase. Fat is the dispersed medium. So this is the oil in water, that means oil in water. And water in oil type means vanishing creams or gel shaving creams, all this comes under this. This is called as various examples for the creams. This comes under water in oil type. This is all about types of colloids. Now, one more important classification is also there in colloids, that is classification based on dispersion medium. Classification based on classification based on dispersion medium. Classification based on dispersion medium. The colloids are again classified into many types depending upon the type of dispersion medium that has in the colloids. If the colloid is this type, based on the type of dispersed medium is present, based on the properties of that dispersed medium, again the colloids are classified into three types. First type, second type, third type. First type is hydrosol. Second one is alcohol. Third one is acrosol. See, classification based on dispersion medium. These dispersion medium are again classified into three types: hydrosol, aerosol, alcohol and acrosol. Hydrosol means in this it is a colloid in which water is generally the dispersion medium. H2O is the DM, dispersed medium. In alcohol, alcohol is the dispersed medium. In acrosol, dust particles or pollutants, simply pollutants, solid pollutants are dispersed medium. These are the three types of colloids that based on dispersion medium. Depending upon the type of dispersion medium, colloids are again classified into three types: hydrosols, alcohols and acrosols. Now, one more important thing, an important classification is based on types of colloids, lyophilic and lyophobic. Again, it is a very important classification of colloids. Colloids are again classified into lyophilic and lyophobic colloids based on interaction forces. It's a very important thing. Based on interaction forces. Based on interaction forces, the colloids are classified into two types. One is lyophilic and lyophobic. Lyophilic and lyophobic colloids. Lyophilic and lyophobic colloids based on interaction forces between what? Interaction forces are present in between dispersion phase and dispersed medium. Depending upon those forces, these are again classified into lyophilic colloids, lyophobic colloids. First we are discuss about lyophobic colloids. Lyophobic colloids. What are lyophobic? First, lyo means what? Lyo means solvent. Greek word. Lyo means solvent. Phobic means phobia, hate. Not interested in another, hating. solvent hating colloids. The colloids which usually show not interested, they are not at all interested to touch or to comes in contact with solvents. That's why these are called as solvent hating, not loving. Solvent hating colloids are called as leophobic colloids. In leophobic colloids, there is no hydration at all. Hydration is a property. This is a molecule. If you place in this water, it can be wetted. It can wetted. It has some kind of hydration enthalpy. But in the case of leophobic colloids, moreover, if you add leophobic colloid to water, there is no hydration takes place because these colloids are water hating or solvent hating. And one more interesting thing about this is these leophobic colloids, when electrolytes are added, for example, I already said electrolytes are added to these leophobic colloids. When electrolytes are added to leophobic colloids, there is a chance of coagulation. Okay, electrolytes copper కానీ సల్ఫేట్ కానీ ఏదైతే ఎలక్ట్రాలసిస్లో ఇన్వాల్వ్ అవుతుందో అట్లాంటివి ఎప్పుడైతే మనం లియోఫోబిక్కి కొలాయిడ్స్లో యాడ్ చేసినప్పుడు దెర్ ఈజ్ ఎ ఛాన్స్ ఆఫ్ కోగులేషన్. దేర్ ఈజ్ ఎ ఛాన్స్ ఆఫ్ కోగులేషన్ అంటే ఏంటంటే దెర్ ఈజ్ ఎ ఫార్మేషన్ ఆఫ్ ప్రెసిపిటేట్, అంటే ఇట్లా క్లౌడీనెస్గా ఒక కాంపోనెంట్ ఫామ్ అవుతుంది. దట్ కాంపోనెంట్ ఇస్ కాల్డ్ ప్రెసిపిటేట్ ఆర్ కోగులేషన్. Coagulation of leophobic colloids based upon action of electrolytes. Now we are adding electrolyte to it. Upon addition of electrolyte, there is a possibility of coagulation of leophobic colloids. Leophobic colloids can get coagulated by the action of small amounts of electrolytes, that is called as leophobic colloids. Now examples for leophobic colloids is, the best example for leophobic colloids is examples metallic salts. These are the best examples for leophobic metallic salts such as silver and gold. Ag means silver, Au means gold, silver and gold. These are the metallic salts are example for leophobic colloids. These are first based on the type of interaction forces between dispersion phase, dispersion medium. The colloids are classified into two types: leophobic, leophilic. First, leophobic. Leo means solvent, phobic means hating. Solvent hating examples metallic salts of gold and silver. Now we are moving on to leophilic. Now leophilic salts or leophilic colloids. Leophilic means leo, same solvent. Leo means solvent. Philic means loving, love. There solvent hating, here solvent loving. Solvent hating and solvent loving. Leophilic best examples are starch, gelatin. Starch, gelatin are the two components which are very, very important and basic examples for leophilic salts. In leophilic salts are, again, leo means solvent, philic means loving. Whenever if you add any solvent molecule to these colloids, it gets hydrated because they are always in contact with water or solvent. So water loving. So these are called as water loving. Now this is all about leophilic salts and leophobic. Now the special case of colloids is protective colloids. This is also very important. I will make you understand what is meant by protective colloids. Protective colloids means these are the colloids defined as the colloids which are added to leophobic colloids or leophobic salts. I am repeating it again, I am clearly highlighting this. Leophobic salts So I am also highlighting with another important color. See, the colloids which are added to leophobic salts to prevent it from coagulation. To prevent it from coagulation. The colloids which are added to leophobic salts to prevent it from coagulation. We already said, whenever if you add some kind of electrolytes to the colloids or leophobic colloids, there is a chance of coagulation. When small amounts of electrolyte is added to leophobic colloids, there is a possibility of formation of, there is a chance of formation of precipitate or coagulation. To prevent that coagulation process, to prevent that coagulation phenomenon, sometimes we may add some special kind of colloids. Those special kinds of colloids is known as protective colloids. Protecting colloids are protecting the leophobic colloids from coagulation upon addition of electrolytes. These are protecting the leophobic colloids. These are protecting leophobic salts from electrolytes. So in this case, these protective colloids, for example, see, I will explain the mechanism. First, this is an example of leophobic colloid. When we add the protective colloid, P colloid, protective colloid, it forms like this, a protective layer in between electrolytes. See, when the protective colloid is added to leophobic colloid, it forms as a protective layer in between electrolyte and leophobic colloid. Then there is no coagulation. Coagulation is prevented here. Coagulation is prevented in this case. So protective colloids are the colloids which are generally added to the leophobic colloids to protect it from formation of coagulation upon addition of electrolyte by forming a protective layer in between leophobic colloids and electrolytes. This is called as protective colloids. Best examples for the protective colloids is polyvinyl alcohols, and gelatins and acrylic acid. Polyvinyl alcohols, gelatin and acrylic acid. These are the three examples for protective colloids. Protective colloids means we know that. So these are the three examples. These are generally added to leophobic colloids to prevent the process of coagulation. This is what protective colloids. Now we are moving to gold number. What is meant by gold number? So gold number is also very important. Gold number in the sense, here gold number is the one that is, it is in contact, it is generally discussed along with the concept of protecting colloid. Gold number is defined as, generally defined as the amount of, here see, I am writing amount of protective colloids, amount of protective colloids, it is defined as amount of protective colloids added to leophobic salts to prevent coagulation. It is defined as amount of protective colloids added to leophobic salts to prevent coagulation is called gold number. Generally, it is especially for 10 milliliters of, normally it is a standard one, it is generally, this is standard thing, 10 milliliters of gold sol. That means 10 ml, 10 milliliters of gold sol అంటే 10 ml 10 milliliters of gold sol ని అదొక లియోఫోబిక్ కొల్లాయిడ్. దాన్ని కాగులేషన్ కాకుండా ఎంత అమౌంట్ అయితే మనం ప్రొటెక్టివ్ కొల్లాయిడ్స్ని ఇస్తామో, దట్ మీన్స్ ద అమౌంట్ ఆఫ్ ప్రొటెక్టివ్ కొల్లాయిడ్ యాడెడ్ టు ది 10 milliliters of gold sol టు ప్రివెంట్ ఇట్ ఫ్రమ్ కాగులేషన్ ఫ్రమ్ ఎలక్ట్రోలైట్. ఎలక్ట్రోలైట్ యాడ్ చేసినప్పుడు 10 ml ఆఫ్ గోల్డ్ సాల్ ప్రివెంట్ కావాలి. దేని నుండి? కాగులేషన్ నుండి. దాన్ని జనరల్గా గోల్డ్ నెంబర్తో ఎక్స్ప్రెస్ చేస్తారు. దిస్ గోల్డ్ నెంబర్, ద కాన్సెప్ట్ ఆఫ్ గోల్డ్ నెంబర్ ఈజ్ ఇంట్రడ్యూస్డ్ బై ఎ సైంటిస్ట్ నేమ్డ్ యాజ్ జిగ్మాండి. Introduced by a scientist named as Zygmundi. Introduced by scientist called as Zygmundi in the year 1901. Zygmundi in the year 1901, and he also given some of the gold numbers for certain kind of components. For example, gold number of gelatin. Gold number of gelatin is 0.005 to 0.01, and now the gold number of hemoglobin is equal to 0.03 to 0.07. So these are the gold numbers of this much amount of protective colloid is needed to prevent coagulation of gelatin and hemoglobin. So this is all about gold number. Now we are moving on to properties of colloids. We are moving on to simply properties of colloids in the sense similar, like for example, these are first properties of colloids is, first property of colloids is, colloids are the examples of heterogeneous mixtures. These are heterogeneous in nature. Second property is the particle size is generally 1 to 1000 nanometers or 10 to the power of minus 9. 1 to 1000 nanometer or 10 to the power of 1009. And colloidal particles can be separated by a technique called as dialysis. It can be the particles, it can be separated by a technique called as dialysis. By a technique called as dialysis. It can be separated by a technique called as dialysis. With the help of this dialysis technique, the colloidal particles can be separated. These are the important parameters, properties of colloids. First property, heterogeneous in nature. Second property, particle size. Third property, it can be separated by technique called dialysis. And fourth property is, we can see the particles with our eye. The particles are visible. The particles are easily visible. The particles are easily visible. The particles are easily visible. And one more important property of colloids is, it shows a phenomenon called as Tyndall effect. Shows Tyndall effect. Shows Tyndall effect. Shows Tyndall effect. Properties of colloids: heterogeneous, particle size, separated by dialysis, easily visible. Fifth one shows Tyndall effect. These are the various properties of colloids. Now we are moving on to industrial applications of colloids. What are the industrial applications of colloids? Just a minute. So far we have studied properties of colloids, types of colloids, classification of colloids. Now we are industrial applications of colloids. Industrial applications usually involves, first, especially these colloids are useful in pharmacology, that means in the medicine, pharmacology, medical applications, especially during like kidney transplantation, like pharmacology. For example, dialysis. Dialysis is an example of technique in which it is used to separate colloidal particles of blood. So it is pharmacology. It also used in drug industry or drug formulations. And third, it is also used in material sciences. And one of the major industrial application is also used in Haber's process. Haber's process, which is a process by which ammonia is produced industrially. Haber's process, ammonia, NH3. Ammonia is produced with the help of these colloids. And some more important application is used in purification of studies, purification of components industrial scale. Purification in industrial scale. So one, pharmacology, that is kidney transplantation or various health issues. Drug formulations. Third, material sciences. Fourth, it is used in Haber's process, especially industry, ammonia preparation. Final one, purification, especially in industrial scale. Purification of products. How much amount of purity is there for the given product. For example, is a paracetamol. Paracetamol is there. At the end of preparation, a specific team will be there. That team, the role of that team is to define and determine how much purity the medicine is produced. 90%, 80%. Based on the purity levels, the work, the effectiveness of the medicine shows an impact on human health system. So in those kind of areas also these colloids are applicable. So these are the examples of industrial applications of colloids. Now we are moving on to previous year's questions, TS ECET 2024 question. That is, once I am reading this question, see, concentrated hydrochloric acid contains 37% by mass HCl. The density of the solution is 1.18 grams per ml. The molarity of HCl is. What is asking here? Molarity asking. Whose molarity? HCl molarity. So I already explained how to calculate the molarity. Now this is how we can calculate this question. This is how we can solve this question. See, simply first concentrated hydrochloric acid contains 37% by mass. Given, first you have to write like this. Given concentration is equal to 37%. Given concentration plus 37 mass in percentage mass, 37% given. Now molarity, we know that molarity is equal to N by V, number of moles by volume of solution. Now we have to calculate now N. N is equal to small m by capital M, we already know it. Now what is the molar mass? The given concentration, that is molar mass, is 37% given. But we have to convert the 37% into grams. 37, for example, if we convert the 37% into grams, it gives rise to 37 grams. 37 grams. Now, what is the small m molar mass is? Now 37 grams. What is the molecular weight of HCl? Approximately 36.5. HCl molecular weight means hydrogen 1, Cl 35.5. 1 plus 35.5 is equal to 36.5. Then it gives rise to molar is equal to 1.0136 moles. 1.0136 number of moles. What is the mole? 1.0136. Now we know that volume of solution is equal to formula. This is the volume of solution is equal to mass of solution by, this is another formula to calculate density. Volume of solution is equal to mass of solution by density of solution. Density of solution. Density of solution. Now given concentration we know that. Now we have mole, we have molecular weight. Now mass of solution means we are now percent means 100 grams. We are calculating for 100 grams. So now 100 by 100 grams by density of solution in the sense, what is the density? 1.18. This is 1.18. Now volume is equal to, volume of solution is equal to 84.74. 84.74. Now if we convert this ml into liter, it is equal to 0.08475, like this, 1 by 1000 into 1 by 1000. Now volume is equal to mass of solution by density of solution. We are now we are assuming 100 grams. 100 grams per density already given 1.18, 84.74. If you convert this ml into liter into 1 by 1000, then it gives rise to 0.08475 ml. Now we have now molarity is equal to N by V. We have now N. What is the N? 1.0136. Now what is the ml value? 0.08475. If you calculate it, we will get it. It is of 12. So first concentration, M, V, density. This is how we can calculate the value of 12. So clear? I think you are very clear with this. Now second question. A colloidal solution can be purified by the method of, I already said in the properties. Colloidal solutions are, we can easily see. So there is a one technique for separation of colloidal particles, that is called as dialysis, without any doubt in it. Now pH value of 0.001 MnOH solution. This is a very important question. I will also make you understand this question. In this question they are asking pH value of 0.001 molar NaOH solution. pH value adugutunnaru. You have to know that NaOH is a strong base. NaOH is a strong base. NaOH is a strong base. So it dissociates into ions completely because it is strong. Dissociated completely in solution because it is strong base. Now there is a formula for this. For example, pH of P, we need OH. OH means in the near place it is a base in the sense OH ion. So P of OH can be calculated by formula negative log or negative logarithm of OH minus concentration. This is concentration, this is pOH. pH of OH ante OH యొక్క pH range. ఇది formula. Now pOH is equal to concentration enta, given concentration is 0.001 minus log 0.001. Then finally P of OH is equal to, if we simplify all these terms, now we get 3. P of OH is equal to 3. We already know that. We know what is the pH scale, 14. For example, pH plus pOH is equal to 14. Now we have pOH. This is 3. pH we don't have, is equal to 14. Then pH is equal to 14 minus 3, that is 11. We finally calculated pH. How? Strong base, NaOH is strong, dissociated completely in the solution. P of OH is equal to, this is a formula, minus log of OH minus concentration. Given concentration is 0.001 then POH is 3, pH plus POH is equal to 14. Then pH plus, this is O substitution here. Now finally 11. 11 is the answer. Next, the solvent not used for green synthesis. What is green synthesis? We know that sometimes we use many kind of things. Green synthesis means anything that can be synthesized which are environmentally friendly. అంటే environment కి harmful కాకుండా ఏ సింథసిస్ అయినా దాన్ని గ్రీన్ సింథసిస్ అంటారు. సో aniline, the solvent not used for green synthesis is aniline. Why aniline? Because aniline is a organic molecule. The general structure of aniline is like this, NH2. Benzene, amine group, aniline. It is an organic molecule. It is poisonous in nature. Poisonous. After the completion of its use, it can accumulate in the environment. So it is poisonous. So it is not used in green synthesis because it is poisonous. It cannot be easily degradable. So it is poisonous. So it is not used in green synthesis. Next, Prussian blue colloid is, this is the Prussian blue colloid because Prussian blue color. If you take this option, this is arsenic compound. It is generally yellow in color. If you take iron, it is red. Generally, it is red in red-brown color, reddish color. This is arsenic compound, yellow in color. Iron is red in color, and ferrous FeCl3 is also orange to brown color. Now, this is the only compound which is blue in color. So the answer is 3, Prussian blue. So this is 3. Now, producer gas is a mixture of. What is meant by producer gas? Producer gas is a mixture of CO plus N2 because CO2 plus H2 is not a producer gas. It is an example for, it is called as water gas. CO2 plus H2 gives rise to a compound called as, that is water gas. So there is no scope of being producer gas. So this is eliminated. CO plus H4, this is also not right because it is a harmful substance. It produces generally finally hydrocarbons. CH4 plus H2, it is an example of, this is also not right. But the only option which is right according to this question is CO2 plus N2. This producer gas is generally produced. How it is produced then? This is generally produced when passed by passing air over steam. Steam ante gali. Whenever we pass air over steam, whenever we pass air or whenever we pass by passing air or steam over coke. Coke in the sense it is a type of ash, carbon. It is a type of carbon. By passing air or steam over coke material, then produce a gas called, that is called as producer gas. So the option 2 is right. Next, this is also a very important question. See, this is asked in the TS ECET 2023. When 2 amperes of current is passed through copper sulfate solution for 10 minutes, the amount of copper deposited is atomic weight given. Here asking amount of copper adugutunnaru. Now first, before this, we have to know what is the concept in this. The concept is purely based on Faraday's first law of electrolysis. It is based on Faraday's first law of electrolysis. Faraday first law of electrolysis. This question is based on Faraday's first law. According to Faraday's first law of electrolysis, the formula is Q is equal to IT. This is the formula. Q is equal to charge, I is equal to current, T is equal to time. This is a general used formula. Now first of all, the given 2 amperes of current given, 10 minutes given. Now we have to convert the 10 minutes into seconds. 1 minute is equal to 60 seconds. 10 minutes is equal to 600 seconds. We know this. Now the time is 600 seconds. Generally electricity Q is equal to electricity passed. This question, electricity passed is equal to Q is I. What is I? Given I is equal to 2 amperes, because ampere is the SI unit of current. So 2 ampere into what is the time? 600 seconds. So it gives us as 1200 coulombs. C is the unit of charge, 1200 coulombs. Now this is first step. Now second step, number of moles of electron passes. How many number of moles of electron passes? Number of moles of electron passes. The formula is equal to Q by F. F is equal to constant, which is generally Faraday's constant, 96,500 Faradays. 96,500, this is the constant for F. We already know that what is the Q? 1200 by 96500 is equal to 0.0124 mole. 0.0124 mole. The number of moles of electron passes is equal to Q by F. We know that Q value from here, 1200. F value is equal to constant, that is 96,500. After simplifying it, we get 0.0124 mole. Now this is the second step. Now third step. I am writing third step here, see. And moles of copper deposited. How many number of moles of copper? Copper, you are asking deposited. We know that copper plus 2 plus always 2 electrons take, it gives rise to Cu. Copper always exists as Cu plus 2, it gains 2 electrons to form Cu. Now mole of copper is equal to, we know that number of moles is equal to this by 0.0124 by how many moles? 0.0124 by 2. Then moles of copper deposited is equal to finally 0.062. This is the moles of copper deposited, 0.062 moles copper deposited. Now we know we have to calculate the amount of copper. Amount of copper is equal to amount. Final step is amount is equal to moles of copper into atomic weight of copper. How many moles? 0.062. What is atomic weight of copper? 63.5. Then this is the right answer. So the final answer is this, 0.394. 0.394 is the final answer. So these are the steps involved in the calculation of this question. Now we are moving on to next question, that is, in the froth fluidation, pine oil decreases the surface tension of the solution. This is a pine oil means, froth fluidation means it is a kind of technique, it is also used for separation. In froth fluidation, this pine oil is generally used as frother or frothing agent. Frother or frothing agent, which is asked in ECET 2023, frothing agent. Because nuraga antam chudandi, nuraga froth ఆ బబుల్ అంటే స్ట్రక్చర్స్ ని పైన ఇస్తుంది. జనరల్ ఏం చేస్తుంది, డిక్రీజ్ ద సర్ఫేస్ టెన్షన్ ఆన్ ద సొల్యూషన్. అట్లా ఫ్రోత్ ఫామ్ అవ్వడం వల్ల ఇట్ డిక్రీజెస్ ద సర్ఫేస్ టెన్షన్ ఆన్ ద సొల్యూషన్. సో ఇట్ ఇస్ యాక్చువల్ గా దిస్ ఈజ్ నాట్ increase the surface, this is also not, does not affect the surface, it is also not. So the answer is 4. Now next question is, the number of moles of solute present in 1000 ml of 0.2 m solution. 1000 ml of 0.2 2 solution. Here asking number of moles. Given, what is given in this question? Molarity is given. Molarity is equal to number of moles by volume of solution. Now we have to calculate first the number of moles. Molarity given 0.2. What is the molarity? 0.2. We don't know N. What is the value? 1000 ml means 1 liter. So we have to write 1 liter. Now N is equal to 0.2 into 1. That is 0.2 moles. So very simple, 0.2 moles. Asked in 2022 shift TS ECET shift 1. Which of the following is true for milk colloidal system? It is simple. I already explained types of colloids based on physical state, based on types of dispersion medium, based on type of various types of classifications. I have clearly explained. In that, dispersed phase is fat globule, dispersed medium is, this is the dispersed medium. Examples for emulsions. In emulsions, oil in water type. Remember, go and check it. Water type, I already make you note of it. Oil in water type. So this is an example. This is an example. Molecular weight of a dibasic acid is M. Dibasic acid means molecular weight of dibasic acid. Dibasic means basicity is 2. That means it can donate 2 protons. It can donate 2 protons very easily. Basicity is 2. It can donate 2 protons very easily. That is called dibasic. For dibasic, molecular weight of dibasic acid M, your question is missing, that is here equivalent weight. Write down this question, equivalent weight. For dibasic acid, if M, then its equivalent weight is M by 2. This is the question you have to remember. So M by 2 is the answer for dibasic acids. Now, leophobic colloids are required stabilizers prepared by direct mixing more stable solvent. This is the stabilizer. Why leophobic required stabilizers? Because there is a chance of coagulation when electrolytes added. So in order to make the colloids, especially leophobic colloids stable, we should add this required stabilizers. This is not right. This is not stable. Solvent attracting colloids, no. So it requires stabilizers. Now, when the phenol and water mix together, the formed solution is called, it is definitely when phenol and water added, system phenol, it is an heterogeneous system, it is also right, heterogeneous and colloidal. I already said, sparingly soluble. When phenol and water added, they are not soluble completely. So it is an example for heterogeneous system. Either it can also said to be as colloidal also. How many grams of anhydrous oxalic acid is required to prepare 1 liter of 0.1 oxalic acid solution? Is very easy. It's also very easy. Here ask, we know that 0. Normality given, molarity is equal to N by capital V. Molarity, normality is equal to weight by, this is N, weight by gram molecular weight into 1000 by volume in weight. Sometimes when the component is expressed in moles, normality and molarity will becomes equal. So it is also considered as weight is equal to, given normality is 0.1 normality is equal to weight by how much, what is the molecular weight of oxalic acid? It is approximately 19.03 into 1000 by 1000. 1, then weight is equal to 90.03 into 0.1 is approximately equal to 9.06 grams. See, normality is equal to same, M is equal to N by V, N or V same, weight by gram molecular weight into 1000 by V means 1 liter, because this is 1 liter. Now 1 by 1000, 1 cancel, 0.1 normality already given, this 90.03 is the molecular weight of oxalic acid. So this is how we can calculate. So 9.0 grams is the right answer. So simple, if the sulfate ion concentration in a solution of Ai2SO43 is 0.25 m, the concentration of Ai2SO4 in the solution is also 0.250 m. Because here the concentration of the solution is expressed in molarity. The option A is right answer, that is 0.250 mole, because concentration is a condition. Concentration is expressed in terms of, this is molarity, expressed in molarity. So that's why 0.25 molarity concentration of Ai2SO43 in the solution also same. Now, in a sample of salt water, NaCl would be considered as simple sample of salt water. NaCl means salt plus water. It is salt solution. Salt is solute. I already many times I said to you, solute plus solvent. Salt is a solute. 30 ml of, this is also very simple. The formula used here is M1V1 is equal to M2V2 simply. See, 30 ml of 0.1 molar more salt solution titrated in acidic medium against 0.1 K2Cr2O7 solution taken in the burette. The volume of K2Cr2O7 solution at the end point after the addition of suitable indicator. The formula used here is M1V1. First, take it as HCl. Take it as, where is HCl? Take it as, for example, this is not HCl, it is more salt. This is more salt, this is potassium dichromate, Cr2O7. Take it as already given. Molarity of more salt is 0.1. What is the volume given against 30 ml of 0.1, 30 ml of volume, equal M2 into V2. M2 means K2Cr2, this is M. For example, first M1 means this is a molarity of more salt. Volume means 30 ml. Next another molarity is 0.1. We have to calculate V2, simple. V2 is equal to 0.1 into 30 by 0.1. Then V2 is equal to 30 ml. This is the answer. Simple. Same question. M1 V1 is equal to M2 V2. M2 V2. Here HCl and this is H2O. We know that already given HCl is equal to 12.6 molar. We have to calculate V1 here. M2 means 3 M00 into 5 liters. Now V1 is equal to 300 into 5 by 12, same as previous question. Then it is approximately equal to 1.19 liters. Simple question. See, this is a formula, very useful formula, and this is molarity, this is volume. 2. When there is a comparison between two components, we should use this formula. So this is all about solutions and colloids. Thank you so much for listening patiently to my class. So be regular to the class and ask any doubts, whatever you want, and make sure of notes very properly, and all the very best to you for your exams. So this is from, and once again I am your Chandra Prakash, and I will get you back with another topic with a fascinating explanation. Thank you so much for listening patiently.